Good evening, everyone, and welcome to the New Mexico Museum of Natural History and Science. I'm Charlie Walter, the director of the museum, and we're very honored to host the second in 4 community forums on our beloved Bosque. It's the hope that through these forums, our community will have a greater understanding of the past, present, and future of the Bosque, the Rio Grande, and Rio Grande State Park. As I mentioned, this is the second of 4 forums. There'll be 2 more in May and June on the first Tuesday of the month, this exact same time, so we welcome you to attend. And also, I wanted to tell you that we're having the first walk and talk, so you can get outside where we all belong when we talk about the Bosque and walk along the river, and that's at 10 a.m. this Saturday. Park at the Alameda open space parking lot, and there's a little information out there on the table on your way out. So if you have a chance to go to the walk and talk, we'd love for you to do that as well. So again, thank you for being here tonight. I look forward to learning with you tonight, and I'll turn it over to Bruce Thompson, our moderator tonight. So here we go.
Thank you. I'd like to welcome you all. I'm Bruce Thompson. I'm a research professor in civil engineering at UNM and former director until this last summer, director of the Water Resources Program. I've been at UNM for almost 36 years. I started when I was 12. You do the math. So I'm a techno nerd, and I read Scientific American cover to cover every month. And I don't know if anybody else does, but at the end of the very last page, they have this wonderful graphic every month. And this one is on climate, the people agree. And it's the result of, I think, 21 public polls, public opinion polls throughout the country, and you know, it's this wonderful chart. And what it says, generally, somewhere around 75, each of the polls report that 75 to 85% of the public agrees that the climate is warming and that humans are part of the cause. But down here, if you probably can't see, there's this big dip, and that dip says, where are my reading glasses? These are the people who consider the issue of global warming an extremely important concept to them personally, and it's about 10%. So everybody agrees it's occurring, but only 10% agree that it's extremely important to them personally. Quite remarkable. So the subject of tonight's forum is the impact of climate change and the impact on the Middle Rio Grande, and specifically on the Bosque. We've got 4 speakers. The format is going to be a little bit different than it was last month. We're going to give the speakers a little more opportunity to talk about their areas of expertise. So nominally, somewhere around 15 minutes. We'll have the 4 presentations. After each presentation, we'll have a minute or 2 for questions if there's anything that you just really got to get out. Then we'll have a conversation amongst the 4 panelists, and then the last 45 minutes or so will be questions from the audience. We're asking that the questions be submitted in written form. And so there are cards that will be passed around. If you haven't got one, you might want to pick up 1 or 2. So with that, you don't want to hear me talk. You'd like to hear our presentation. The first speaker is Dave Gutzler, who is a very close personal friend. Dave is a professor in the Department of Earth and Planetary Sciences at UNM. His teaching and research focus on the causes, impacts, and predictability of climate fluctuations on time scales of months to centuries. He tells me that his class, his climate dynamics class, is how to build a monsoon. Dr. Gutzler currently serves on the scientific oversight panel for NOAA's Climate Prediction Program for the Americas and was a member of the most recent Intergovernmental Panel on Climate Change, the IPCC. So with that, I'll turn over to Dave Gutzler. And
well, thanks, Bruce. Since he started off talking about polls, maybe it's appropriate that I see that science is listed separately from climate change in the title here, although I'm going to try to stick to science here, and I will do my usual gig of showing you too many line graphs and charts and stuff. But my task here in the next 12 minutes or so is to give you a very brief overview of large-scale aspects of climate change and climate variability, and in hopes that of setting up the next few speakers. So if I just do this, somewhere if I keep clicking, there we go. Okay, so what I'm going to do is show you some graphs that focus on local and regional climate variability and change. And the first thing I've got here is a temperature time series, actually two of them since 1950. Those are both temperature curves, but they're expressed as heating degree days and cooling degree days. Those are the kinds of temperature metrics that affect your utility bills. So if we, without going into the details of what heating degree days and cooling degree days are, they're effectively an integrated measure of temperature for winter at the top. Those are heating degree days, and cooling degree days at the bottom. That's what happens in the summer. Upward, I flipped the axes so that upward trends in the graphs mean warming. And so what you see is that there is a noticeable upward tick. It's certainly not steady with time. There's lots of interannual variability. We have hot summers and colder summers, hot winters and colder winters. But if we fit little straight lines through those graphs, we see that over the past few decades, there's been 10 to 20% changes upward. That means fewer heating degree days, which means warmer, or more cooling degree days in the summer. That means warmer. And so that doesn't seem like a huge amount, and certainly the trend does not overwhelm the interannual variability, but I can assure you, since I work with the PRC in some respects with these plots, that that's enough to affect your utility rates. Okay, so in a very broad economic sense, we're already seeing warming, both winter and summer, that are significant the way an economist would define significant. And so as we'll see, trends of this magnitude make a difference in other temperature-related metrics around New Mexico as well. There's a lot of good reason to think that the upward trend in temperature is going to continue. So I'm skipping lots of steps here and showing you a scenario of temperature change. I picked the one for northern New Mexico, which has hydrologic relevance. So what we're looking at, if we look at the bottom left, the red curve is for summer this time, and the blue curve is for winter. To the left of the dashed line for the 20th century, that's data. So those are actual seasonal average temperatures. The blue curve at the bottom is for winter, and the red curve is for summer up in northern New Mexico, averaged over that climate division 2. And you can see that it's kind of trending upward, sort of modestly, with lots and lots of variability, more variability from year to year in the winter than in the summer. That's all well understood. And if we take a plausible scenario for increasing greenhouse gases and put it into a climate model, then we can append future projections to the data. So to the right of the dashed line there is a model simulated trend from the previous IPCC report, onto which I've superimposed historical interannual variability, just so you can see how big the trends are relative to the variability. So what happens over the course of the 21st century is, in these simulations, is that the trend really does start to emerge from the envelope of interannual variability. It hasn't happened yet, as we saw in the previous slide, but by the middle of the 21st century, by 2050 or so, then summer temperatures in particular have kind of left behind the envelope of historical variability that we see in the data. So if anything like this happens, we'll be looking at really big changes in the Bosque and throughout the Southwest, and really throughout the world. It's important to keep in mind that this is just a projection. In fact, this projection looks an awful lot like the one you can see out in the climate change exhibit in this museum. That's not a surprise, because I put that one together too. And we can change the slope of those trends in the 21st century by just choosing a different greenhouse gas scenario in the model. So depending on future policy choices and so forth that go way beyond local decisions about the Bosque, that temperature trend could get bigger or could get smaller, but all the models simulate trends headed up at some rate. in this particular scenario, if we apply it to Albuquerque, basically the climate of Albuquerque in terms of temperature becomes effectively like El Paso by the end of the 21st century. So think El Paso as a sort of plausible scenario simulated by climate models given a plausible assumption of greenhouse gas increases. And as you can see, this is not just a local effect. There's a map of projected temperature changes consistent with what I just showed you, and we're looking at temperature changes of 3 to 4 Celsius over the course of the 21st century. That's roughly 7 degrees Fahrenheit, which is the rate of warming that I just showed you in that previous graph. So this is embedded in a very large-scale temperature change pattern, and I don't want to go into the details of that in a lot of respects other than to say that it just gets warmer all over the place, especially on the continents. Here we are in the middle of the continent, and so it's kind of a hot spot. Precip is a lot more ambiguous. There are simulations of precipitation change, again, from models. There is some tendency maybe for decreased precip in the winter, although it's much more pronounced in Mexico than it is in the US. If you squint, you could see that up near the headwaters of the Rio Grande, we're almost in the node between brown colors, which is less precip, and blue colors, which is more. So the effects on precipitation are a little bit ambiguous, and in the summer the models are all over the place. So we have a weak tendency in the lower right, maybe for a little less precip, but one model changes the monsoon much differently than another model. And if we look at the trends in precip and superimpose historical variability, play that game again, then what you see, there is a trend in precip there in the lower left, but it's real small compared to the interannual variability. So the overall picture of climate change that I get from studies like this is that we are facing a likely climate future that involves very significantly warmer temperatures, but much less discernible changes in total precipitation. But here we are living in an area that has absolutely gigantic interannual and decadal variability as shown in these graphs here. So lots of variability in precip, warmer temperatures, and the effect of that hydrologically is that when we do have a dip in precip, like we're in the midst of right now, as the climate warms up, the effects of that get more pronounced. So the historical variability in precipitation shows up in things like streamflow. So here's a reconstruction of more than 500 years of Rio Grande streamflow at the Ottawa gauge produced by a group at University of Arizona and the University of Colorado. I've just replotted it here. And what we see based on tree ring reconstructions is that plus or minus 20% on decadal timescales is typical of variability over the last 500 years. So that's just natural variability, and it's huge. So once again, droughts and pluvial cycles have always been with us, but what we expect is that as the climate warms up, the effects of those pronounced droughts become bigger because for reasons that we'll talk about here right now for a couple of minutes. We've also seen, back to data, over the past 30 years, we've seen the effects of that increase in temperature in a number of different ways. These curves show changes in snow melt and snowpack, and the changes are less pronounced at high elevations, which are the two upper curves, and more pronounced at lower elevations, which is just what you would expect if the same amount of snow is falling on the ground but it melts earlier. So we're seeing the effects of earlier snow melt already, and just over the past 30 years, if we squint at the y-axis, you see that melt date averaged over the Four Corners region in the Southern Rockies has shifted about 2 weeks earlier, just in the last 30 years. That's also expected to continue. So climate model simulations that include anything like a 7-degree Fahrenheit change in temperature over the course of the 20th century, not surprisingly, have big effects on snowpack. especially down here in the Banana Belt for snowpack. We're right kind of on the margin of the snowpack region of the Southern Rockies. The curve on the left is a simulation of what could happen in the Gila River watershed, where snowpack actually just effectively disappears by the end of the century. On the right are the bloody red colors, indicate changes in snowpack simulated by a climate model of anywhere from 10, 25, or even 50%, most pronounced in the warmer mountains on the edge of the snowpack region. If snow melt is happening earlier and the monsoon is simply variable, one of the things that affects, that matters for the Bosque is just the length of the spring dry season. So we came up with a metric that is just we defined a hydrologic spring season in which spring starts on snowmelt date, as we defined in that previous graph, and spring ends when the monsoon starts, typically around the end of June, early July. And when you do that, you get a curve that looks like this. Once again, it's noisy, but the hydrologic spring defined this way is about a week longer now than it was 30 years ago, and this metric too is projected to increase. So what we expect to see as the climate warms up is a much longer period in the spring after the snow melts, but before the summer rains start, and what that leads to is soil moisture drying out. So we're at the same time that plants love it if they have water, because temperatures are rising. So in a riparian watershed, as long as there is water in the river, then the plants will increase their demand for water because the growing season is longer. But if you don't have access to water, then soils tend to dry out as the spring dry season increases. Okay, maybe I'm going to quit there. I've got lots more I could say. Do you want me to keep going, Bruce? Yeah, well, that's the problem. We'll just keep talking as long as... So here's our introduction to hydrology, and Ariane Pinson is going to have a lot more to say about this. I had an undergrad student looking at the Pecos River, which is in some ways an easier system to study than the Rio Grande because the upper Pecos is less managed and we can look at natural stream flows easier. So here's what's been happening in the upper Pecos for the last half century. There's our temperature increase on the bottom, but now we've filtered out some of the interannual variability just by running a decadal average through the time series. And look what's happened in the upper Pecos there in the lower right. Since 1950, the temperature's gone up more than 2 degrees since 1950 or so. Up it goes. At the same time, the last few decades, that's the curve above it, have been wet. We've had a lot of, the last few decades of the 20th century were among the wettest of the millennium. That's come to a screeching halt here over the past few years. And so flow timing above that, it means earlier. That's consistent with the earlier snowmelt. So as the river reaches its peak earlier, spring season gets longer. The curve in the upper right is the one that's potentially troubling. It's simply a measure of how much stream flow is coming down the river as a function of how much precip fell in the winter, right? We've got lots and lots of variability from year to year in winter precip, and you would like to think that the spring seasons following wet winters are going to be high streamflow years. But as the temperatures warm up in the spring, evaporation rates go up, and so the ratio of the flow in the river in the spring divided by how much precip falls in the winter is going down, and it's now at its lowest point in the record, and that's consistent with what we see on the left. There's no overall trend in stream flow in the Pecos River over the last half century, but we're seeing a lot less of that flow happening in June and more of it happening in March and April earlier in the season as the snow melt happens earlier. And that lengthens the spring season and allows the landscape along the Pecos River to dry out during that extended and warmer spring season. Okay, now I really will stop and let Ariane take over and tell you an awful lot more about the hydrology that we've seen and have expected. So she's next.